You deposit $500 each month into an account earning 5% interest compounded monthly. We have a bunch of questions. Let's see. How much will you have in the account in 20 years? How much total money will you put into the account? How much total interest will you earn? All right, so here we're not just depositing money once. Each month we're depositing 500. So this just isn't the future value of compound interest present value. Here, this is called a savings annuity. And the savings annuity formula is usually often you'll see PN instead of future value, but it's the future value we're calculating. N here would be my 20 years, my capital N. And it's going to be D, the payment, times parentheses, and then we see the compound interest base, 1 plus R over K to the power NK. So we're using K equals 12 for monthly here. And then we have a -1 parentheses, and that's divided by, and some calculators need a parentheses in the bottom for R over K. So here, K is my compoundings per year, N is the number of years, R is my interest rate, and D is my $500 each month. So for this instance, we'll have 500 times parentheses, 1 plus 5% is 5/100ths, split in 12 times a year. The power is going to be 12 times 20. Close the exponent, subtract 1, and then that's all divided by that proration of the APR. So that would be our 5/100ths, 5% over 12. So you need all of these parentheses on most calculators. Let's try. So I'm going to start off with a fraction. 500 times parentheses, 1 plus my interest rate, 5/100ths over 12 because we're compounding monthly. And I want to raise that to the power, parentheses, 12 times 20 years, 12 times 20. And I have to close the power, get out of the exponent position to subtract the 1. And then in the denominator, with this calculator, I'm pretty sure I don't need parentheses, but I'm going to put it in to be safe. And then I have a fraction in here of my APR, annual percentage rate, split into 12 months in the year. Let's see if I typed it correct. My D is 500, parentheses. Then here we have the compound interest base to the power. That looks good. Subtract 1. All right, so it looks like I should have $205,516.83. So here, this would be approximately this amount. So that's how much money we'll have in 20 years. Comma in there. Now, did we pay that much? Well, let's see how much we paid. So that's part A. To figure out how much we paid, well, we made $500 payments each month. So we're going to have $500 times 12 months. So that'd be 1 year's worth of payments. And we're doing that for 20 years. $500 times 12 times 20 means we paid in $120,000. Well, this looks like a good investment. Go. And I guess that's exactly, not approximately, equals $120,000. So that's what we paid in. We ended up with this much in our account. The difference between the two would be the total interest that our $500 payments made over time. And the first one made the most because it was in there the longest, so on from there. So part C, if I take my $205,516.83 that will be in my account at the end of 20 years, and I subtract my 120,000, the difference in what I paid and what I get should be my interest, my profit. $205,516.83 minus that previous answer, 120, means I have a profit of 85,000 plus. And so this would be my total interest earned over that time. Of 120 are my total deposits. And again, this right here, the 205,000 is the future value of those payments. Future value of this annuity.